Okay, to just go through the basics of what is actually happening here, we've got our mains switch for the whole lab. So if I turn this off, the voltages to the inverter get cut because my circuit breakers for my inverter are connected after this. And then also the circuit breaker that's feeding the source B of my transfer switch is also in this distribution board. So this main breaker is feeding a distribution board that could be labeled my non-critical loads. Then to the right of that, I've got a meter, three-phase meter, and I've just got that in my board here to symbolize when the voltage is present and not on my backup circuit. So this is a meter feeding my critical circuits, and when it turns off, when I turn off my critical circuits, the meter got no power, the LCD is off. So it's just a very good indicator for this video when my voltages are present on my backup and how fast my backup transfer is. If it's very slow transfer, the LCD turns off. Then I've got an ATS, a transfer switch. This is effectively a transfer switch as well, but this is the one I'm going to demonstrate today because it's slightly more complicated. You've actually got to do the connections for the automatic transfer to happen. Whereas a switch like this, it does the detection already for you. This has got some extra customizations that you can do, but we're not going to worry about that. This is a very default state. Basically, it detects when the voltage is there. If there's no voltage there and there is voltage here on source B, then it will change over to B. If there is voltage on A, it will stay on A, and that's only if it's in automatic mode. If I flip the switch and make it manual, I can flick it wherever I like. Okay, so this is a transfer switch, and I've got in source A the output of my inverters. So the reason why I've put my inverters on source A and not the grid on source A is because I want the default state. When there's no voltage on anything, no voltage on grid, no voltage on the inverter, I want it to go to source A. And that is because when there is a grid outage, the inverter actually loses voltage for 20 milliseconds. And this thing will see no voltage on both for 20 milliseconds. Then the inverter ups that voltage to 230, or your set point, and then this thing will start doing the transfer after 8 seconds, and it takes 8 seconds to do it, which is extremely quick, but it adds those two delays together. So 20 milliseconds plus the 8 milliseconds, it will actually cause something like your meter to turn off and possibly your desktop computers. So I would highly recommend setting your backup of your inverters, your output of your inverters to source A so that the default state is A. And then my grid connections are coming in source B, and then just below that is my output, and that's where I've got running through to the input of this RCBO, and then the output of this RCBO is running through to my meter, and that's running through to my, it could be and would normally be like a distribution board for your backup circuits, but I've just got it running through to a 20 kilowatt heater in the other room. I've mentioned this very quickly. It's just a RCBO, an RCD plus an MCB for my backup circuit. So the complete output of my ATS is going to that, and then the output of that is going through to my meter. Then these two is the output of my inverters. So my hybrid 1 is here, and hybrid 2 is here, and phase 1, 2, and 3, and my neutral is connected up to the source B of my transfer. And then the outputs of these two circuit breakers, which are independent of each other, is going through to my source A of my ATS. So that's it in a nutshell. And just to do some demonstrations, so this is pointing to when there's power on my backup. And if I trip the grid, we would expect it to just remain on source A because my inverters are outputting voltage. These are also very good indicators that there's power on my circuit, and you can see here that I've got power on my source A, which is my inverters, and we would expect this ATS to just stay in its state because the inverters are outputting the voltage. So I'm just going to simulate that. So I'm going to trip the mains for the whole lab, and my lights are going to dim because the lights for the lab are on the non-critical circuits. I've got some other lights which are also on the backup, so I'll get you'll see a slight difference. Okay, I'm just going to, there you go. And it remained on source A, and the voltage on B is non-existent. It doesn't have it, so I could touch that. And the grid is gone, but it remained on backup, and my meter remained on. So it was a fast enough transfer, and this is when the inverter did the transfer. So that was a 20 millisecond off time, which kept that up and would have kept up desktop computers, televisions, all those types of loads. Resistive loads wouldn't even notice it. Your LED lights, you might see a flicker. Our eyes can detect 60 hertz, and your fluorescents will do their thing, obviously. Just turning the grid back on, the inverter will synchronize. This position is still connected to the backup, so the output voltages here will actually be your 230s, which is the output of the inverter. My grid voltages are more the 240s. And that's how I know it's connected to the backup. And then my inverter will take about 60 seconds to connect back up and synchronize to the grid voltages, and then it'll whack it in, and the source A will effectively be the grid voltages, because the inverter will be letting the grid voltages through it and into source A. Now, just to simulate something else, as I highlighted earlier, there was two major advantages to having this ATS. The one is that you can have more power, so effectively I can have 125 amps through the system. And then the other major advantage is if your inverters fail, if your batteries fail, solar panel fail, if anything goes wrong, if these breakers trip, it will detect that there's no voltage on the backup, and it will transfer back to the grid voltages. So this system here is finding where there's voltage on either, and it's transferring to the one where there's voltage. So I'm just going to trip my inverters. These are the breakers on the output of my backup, and I trip them, and you can see very, very quickly the meter did not turn off, and there's my grid voltages. You can see that they're 240s, so that is the grid voltages, and there's no voltage for the output of my inverters because I've isolated these, and source B is still live because my main breaker, which is running through to my distribution board and back through to source B, is still on. Very, very nice.